Okay, in this video, I'm going to be showing you how to solve a set of nonlinear equations in Matlab. And the example I'm going to use is this example right here. So I have two equations with two unknowns. So my two equations are f1 and f2, and my two unknowns are x1 and x2. So these equations could be manipulated and written in a different way, such that maybe for this first equation I had, maybe it was originally written like this: x1 minus x2 is equal to x1 squared minus 0.5. That's fine. Okay, it could have been written like this, but in order to solve nonlinear equations, the first thing we need to do is turn it into a roots finding problem. So we move everything to one side. So I move all this to this side, and then that's how I get f1 right here, this equation. So everything's set equal to 0. So we're looking for the roots of these equations. So I'm going to go ahead and show you how you can do this in Matlab. Let's see, before I kind of do that, these two equations can be thought of a vector valued function. So in Matlab, I can think of these two equations as vector valued functions. So I could say I have f and it takes a vector x, okay, and it returns a vector y, okay. So if I gave you the values x1 equals 1 and x2 equals 1, I could formulate that as a vector. So I could say x equals, this is Matlab syntax now, 1, 1, and then pass that into my function. What I'm going to get out is a vector y that is the values of f1 and f2. So I'm going to show you how to define that function in Matlab and then how to solve it using fsolve. So here I've got Matlab open, and I'm going to go ahead and show you how to do this. First of all, we need to define our functions. So our first function, I'm going to call it f1, and I'm just going to define it here. So I'm going to say f1 equals it's going to take x, which is going to be a vector, and the first component of that vector x is going to be the variable x1, and the second component of the vector is going to be the variable x2. I've already forgotten what our equations are. Hold on, let me come up here and do this so that we can see these equations. So f1 was equal to x, the first component that stores x1, x1 minus x2. So I'm accessing the second component of the x vector, minus x1 squared plus 0.5. Alright, so now I've defined f1, and I should be able to pass in a vector to it and get a value back. So let's test that out. If I type in f1 and I pass in, well, let's define an array. Where do we want to evaluate it? Let's say we want to evaluate it at the point a equals 1, 1, like I was talking about before. I'm going to make this bigger now. A equals 1, 1. Now I can type f1 of a, and it returns back a number, minus 0.5. So that's literally saying take x1, which is 1, subtract 1, now we're got 0, take minus 1 and square it, well, that's 1, and then add 0.5. See, that doesn't seem to add up. Is that really what it should be? Did I make a mistake here? So here, if we plug in 1, 1, let's actually do the math, make sure we can do it by hand. For F1 here, if I plug in x1 equals 1 and x2 equals 1, I get 1 minus 1 minus, oh yeah, x1 squared minus 1 plus 0.5. Yeah, okay, so that's equal to minus 0.5. Yep, okay. So we were right. Matlab was not leading us wrong here. Alright. So now I need to define F2. So I'm going to define F2 in the same way that I defined F1. But it's going to be a different equation. And I'm calling it F2 this time. So the equation for F2 is given right here. So I have F2 is equal to x2 minus x1 squared plus 5 times x1 times x2. Alright, and then I could pass in F2 of A and get a number back, 5. Alright, so I've defined those two functions, but now I want to define this vector value function down here, which is y, you pass in f of x, you pass in x, and you get back the vector f1, f2. So to do that, I can say f, this is my function, it's going to take a vector x, and now it's going to return a vector f1 of x, and I'm going to make it a column vector f2 of x. Okay. So now I've created that function, and now I can evaluate this at A, and I'm going to get back a vector now that stores f1 and f2. Alright, so now that I have that function, I can use a built-in Matlab function to solve this set of equations. Now before I do that, well, actually yeah, I'm going to show you how to do it first, and then I'm going to talk to you about the solution a little bit. So the function is called fsolve, and if you just look at the documentation for fsolve, oh, you're here. All right, I'll be out in a sec. So sorry, that was my wife coming to pick me up. Anyways, the documentation for fsolve says it's going to solve some set of nonlinear equations and all you have to do is you have to pass in this function that we defined, f, and some starting vector, and then it will return the solution. So it's pretty straightforward. You can read all about this if you want to, if you're interested in it for more details. I just kind of want to demo how to do it. So I could say my solution is equal to fsolve, pass in my function f, and I'm going to give it a starting spot. Maybe I'll just give it A as my starting spot, and hit enter, and it says, spits back a whole bunch of information, but it says the equation solved, and this is the solution. And now this solution is initial guess dependent. So if I gave a different initial guess, say I did, oh, I don't know, 1.5, 1.5 as my initial guess. Oh, no, that gave me the same one. Sometimes it'll give you the same one. Let's give it maybe 0.5 and 0.5. There we go. Gives me a completely different solution. So, and why is that? Well, for nonlinear functions, sets of nonlinear functions, there's possibility of having multiple solutions. Just like when we were solving linear functions, remember when we were doing 3x3 matrices, we could think of the solution as where 3 planes all intersected. Well, sometimes the 3 planes intersected along a line, and then there was infinite solutions to that set of linear equations. Well, I wrote some code to plot these two f1 and f2 functions. I can just call that here nonlinear example. And okay, so this is f1, the plot of f1. And now I can actually come in and plot the other one. So surf x, y, y, f2. Let me show you that plot now. Okay, now I've got 2 curved surfaces here, and you can see they intersect along a line, and my x values are between 0 and 2, and my y values are between 0 and 2. We can see that these 2 planes intersect along this line, and so depending on my starting point on the xy plane, I might start somewhere, and then my fsolve is going to converge to a solution, one of the solutions along this line where they intersect. So there's technically infinite solutions to this particular problem. Anyways, but now you know how to use fsolve, or at least just in a very basic way, and you can learn more on your own, but hopefully this video helps get you started, and I'll see you in the next video.